So, welcome everyone, and thank you for joining us. This is a fireside chat on Beam security, and we're happy to have here Maxim Fedorov. If he needs any introduction at all, Maxim is at WhatsApp responsible for core infrastructure, which means he's operating Beam applications at a scale that most of us can only dream of. He also contributes to OTP. The PG module you may have seen, he made improvements to the TLS distribution protocol. And he's also a co-founder of the Erlang Ecosystem Foundation and the security working group inside the EEF. So thank you for joining us, Maxim.
Thank you, Bram. That was a very impressive introduction. I, however, hold non-impressive title of just a software engineer or performance and scalability engineer, while you, Bram, is a head of software security at Blue Coat, and you are the main, I think, contributor to the work done by a security working group. For example, I'm pretty sure everyone is aware on secure coding guidelines and secure coding and hardening guidelines for Erlang applications, for Beam applications. So welcome, Bram. Happy to have you here.
Hey, well, thank you. So what we're going to do is we've selected a few topics that we want to discuss. This is basically a back and forth between Maxim and myself. And we would also very much like to hear from you. If you have any thoughts, questions, topics that we maybe should touch upon, please do let us know in the chat or in the Q&A. I'll try to keep an eye on this if I can juggle between all the screens. I also opened a poll, so I will maybe also have a look at the results of the poll at some point. But let's first start with just covering the basics. So Maxim, so WhatsApp has been very successful using the Beam, but that was a kind of a decision going from the start, right? The company was founded basically on Beam technology, but in other companies it's often an uphill battle to try and get the Beam adopted for a variety of reasons. But here we're mostly interested in security. So people say, where am I going to find information about securing the Beam? And maybe I'm better off sticking to something that's widely documented in books. So what would be your response?
So first, yes, let me start this with a quote from very old article from Wired Journal, I think, where they quoted one of two WhatsApp co-founders. There was Jan Koum, and they asked him, hey, was it a good decision to actually use Erlang? And he answered that, yes, it was probably one of the best decisions that we ever made. Erlang, and another one he told about FreeBSD. So we are no longer using FreeBSD, but Erlang is still with us. And therefore, I can definitely say that, yes, it is a good kind of technology to start with, but yes, it has interesting implications of using it. It is definitely. I will make a few references to the previous talks. For example, there was a great talk from 2014 by I'm pretty sure it was the Australian guy. I think you remember. I'm very bad at names. Garrett. I'm pretty sure it was Garrett who was literally saying that one of the biggest problem of the whole Beam ecosystem is just it is so hard to find right people who can actually do things, who know how to do things with the Beam itself. Because as you mentioned, yes, there are books saying, okay, you call these functions in C, you make these kind of certificates in OpenSSL, and that's it. But I don't think there are many people who know what to do, who can write these guidelines to for Beam ecosystem. This is why I think you are the first person who actually came up with the security guidelines and hardening guidelines. That's one thing. Another reference I will make is for today's Quinn's talk of the very morning, where there was another reference to Joe Armstrong saying I wish all processes in the world can connect and send messages to each other. As soon as I start thinking on that, I'm starting to get the impression of, oh, please don't do that, because if processes can freely send messages to each other, what a security hell it could be. Like, this is probably one of the biggest problem that I can see with the Beam, and there are so many various recommendations how to actually break processes from sending messages from one to another. Because, like, in Linux, if you want to send some signal from one process to another, you have to jump through quite a number of various hoops. Here in the Beam, you can send the message from here to, I don't know, a node in Japan, and that is definitely one of the problematic things that still needs to be solved within the ecosystem. But some things are definitely easier, for Erlang to just basically to tackle. Like, a good example would be like the whole class of errors, I think, that contributes to 90-something% of security attacks. These are buffer overruns. And Erlang is not really susceptible to most of those, if not all of them. Yes, there may be some bugs in the Beam, but so far, maybe it hasn't been scrutinized well enough, but so far, again, I haven't seen any problems with that so far. And of course, like, there is a community around, like ourselves, to be honest, that will definitely help with setting up with these best practices and so on. Maybe we aren't huge, but what I really value within Beam and the community is that people are very open, and you can always get some help, be it like on a forum. It can be even not the right forum. I can easily get help on Elixir forums to set up the Erlang security correctly. Now that we have Erlang forums as well, I think it's kind of easier to achieve what we need. But still, even before that, the community was so helpful that it was probably something that drew me to not just the ecosystem, not just the Beam languages itself, not just the work that I do, but also to the people that I work with. That would be my answer. And what do you think, Bram, here?
Yeah, well, so I was also thinking about Quinn's talk this morning, where she was talking about telecom background of the Beam, and of course, if you go back all the way, so the environment in which Beam applications were deployed was so different from the public internet that we are now deploying applications on, and so security really wasn't at the forefront. These applications were deployed in a central office in a building with a guard and 6 badge readers at every door. It's completely different. So of course, over time, people have enhancements have been made. But like you said, some things are simply inherently insecure. You can't just connect two nodes to each other and expect one node to be more privileged than another. The 2 nodes are equal. They can do anything that they can do locally, they can also do remotely. So that's a challenge. But on the other hand, as you also said, in some areas, the Beam just is a better point to start from. For example, you mentioned memory. The memory model, which is, of course, a strong case, but look at availability. Availability is also a security concern. Now, Erlang is very, very strong, of course, at keeping applications running, even in the face of problems, whether those be accidental problems or deliberate attempts to bring a system down. Now, you can't stop a distributed denial of service attack simply by running on the Beam. At some point, any system will just give in. But the first step of availability is to make sure that like bad input, for example, won't crash your application. It might crash this particular client that's currently trying to connect and trying to mess with you, but that's their problem. But at least it won't bring down the system for the rest of the users. So I think there are definitely advantages. But yes, it can be a challenge to find resources specifically tailored at the Beam. But then again, a lot of security, I think, is also just the mindset, right? You learning to think a certain way about getting into the head of an attacker. Like, how might someone try to compromise my system? What do I have to keep in mind, and that goes all the way through the stack. It goes through the operating system, the network configuration, the beam, but also like application logic, web interfaces with all the usual suspects of cross-site scripting, CSRF, all that stuff. So the beam layer is only part of that. Now, one more thing, I do want to have a look quickly at the poll, because you said that a lot of people said that, or that Gareth said that it's a challenge finding people with the right skill set. And that's actually the number one answer to the poll, is people said they have difficulty finding people, I guess, on that intersection between knowing a bit of Erlang, a bit of Elixir, and also having the security background to try and apply that. And I guess that's a challenge that we have to work on to get such people interested in the beam, and I guess that's actually a more broader problem, getting people. So another topic that people sometimes mention is that the beam hasn't really gotten a lot of scrutiny from security researchers. So if you look at the number of CVEs, for example, that's been opened against Erlang, there's a handful of them. Now, you could say maybe that's a good thing. It's a good sign. There's not a lot of vulnerabilities, but a lot of people would actually say, oh, it might just mean that nobody has really tried. So maybe you're better off running PHP, even though PHP has God knows how many CVEs open to it. But at least you're a part of like this community of thousands, millions of, well, tens of thousands of PHP developers that probably know how to keep a system up and running. So how can companies like Cisco, Ericsson, WhatsApp, Klarna choose this kind of obscure platform?
I think I have quite a good answer for that. So when someone talks of PHP, at least in my understanding, these are like a huge, monstrous code bases with like an insane amount of dependencies and like millions, if not billions, of lines of code. Now, when we look and see how simple, how concise, how short the Erlang programs are, and how small the whole amount of code that is there to make the system run, it is like 10 times less, or I don't know, maybe even 100 times less than what we see in conventional systems. And that makes a real difference, because now there is much smaller attack surface. So literally, yes, of course, if you increase your system size, if you increase your amount of code, if you double your amount of code, then you are actually having like a much larger attack surface. This is what we see in many other languages. So as soon as you add more code and you add more interactions between different pieces of code, you create more of that surface that people will exploit through, and that people will use CVEs for that. So it's not kind of the problem that the Erlang the Erlang systems are small, but it's also an advantage, because like if it's small, it is just easier to make it more secure. It is just easier to have less errors in there. I even kind of want to mention the interesting formula that I heard some time ago, like some Albert Einstein made it. It was written like this way: E equals to MC squared. So errors equals to more code squared. Since Erlang doesn't have that much code as PHP or any other systems, it actually brings less errors into our systems. And that's why we can reason about it. That's another advantage that we have over Erlang, because we can easily reason about what has happened. In the languages that don't have immutability, you really don't know, because like something happened, something overwrote my memory. I have no idea what it happened. Like, how did those invaders pass by all my security things? Like, but in Erlang, you see, oh, I have a call stack, and I actually know everything that was in the heap of my process. I can just go and observe everything that was happening. I can reproduce the situation because it's functional programming. And next time, I'm sure that if this happens, I know that there will be the same step or there will be the same data, because I have everything saved in here. It, however, poses another problem, like, for example, how do I scrub my security keys from the beam? But that was more on the first question rather than on this specific topic. So not necessarily immutability gives us good benefits, but also sometimes create troubles for that. So basically, the amount of changes that are made to the platform make it reasonably stable, and therefore, since like the development speed of the platform is not as fast as anything else. So basically, usually the vulnerabilities are created when the system like has explosive growth, like it happened with PHP, for example. And with so like fast growth, it's just impossible to even properly test all the combinations of all the software, and that leads to like difficult ways to get into your system. With Erlang, it is not the case yet. But I would hope that when we grow, we will still retain this ability to test the system in all the proper ways. So there are less ways for intruders or attackers to come by. So even if we expand the attack surface, it will be still possible to reason about it. It will be still possible to figure out how to avoid that happening for the next time. That's at least my thinking.
Right. Well, so this also goes back a bit to one of the responses to the poll. I asked, one of the options I gave there was the things that people might be concerned about is the availability or the quality of libraries for things like authentication, crypto, and stuff like that. So some people do think that that's a concern, but like to your point, I think the community it's full of a lot of smart people. Some of the fundamental components that we all use to build on not just the Beam itself and the OTP libraries, but also the third-party libraries in the community are made by smart people that maybe this sounds arrogant, but I think we are lucky to have some people in this community who know how to build this stuff. And in PHP, I think you can get probably good quality code, but I think you can also find some really crappy stuff. And this, I'm not picking on PHP specifically. That's just an example that popped into my head, but I'm sure the same can be said about Go or Ruby or Python or JavaScript or anything. So we talked a bit about some strong points, some weak points, but obviously, going back to the very first point that was made, that there is a lack of, expertise, resources. So has things over the last few years have things improved, do you think?
I would say definitive yes, but I don't think it happened because either the language or the ecosystem experienced more adoption. What I think has happened is the world is getting more and more connected, and we are trying to help to do that, in fact. What I mean by connected, like 5 years ago, I wasn't aware even of any company that was using Erlang, except for Ericsson, of course, just because how do I even know that the people are using Erlang? And I was so amazed to know that, okay, Riot Games, they are using Erlang. Oh, half a year ago, I accidentally discovered that Samsung is using Erlang for their ads platforms, and wow, and they have been using it for many years, and we didn't know. So there are many of those unrelated or kind of unconnected silos or communities or even sub-communities, but people just don't know. So it's not the problem that the adoption isn't growing. It's the problem that we don't know. Even today, I just discovered 2 people from a company that literally sits almost next to myself, and I have never heard of them using Erlang because it is a well-kept secret. So what I think is that situation improved, but not with the ecosystem growth per se, but with more and more people getting connected. And that's where the tools, the instruments that are being created all over the internet, helping to just demonstrate how big the actual community is, and eventually maybe it will result in not as visible fragmentation as it is now. We can have multiple implementation of the very same thing created by different companies, but none is considered to be a standard. So how we can do that even better through bringing more of those tools and mediums. Like for example, I am very grateful to Ashton for creating the Erlang forum, because this was, I think, this has been discussed for, I don't know, many years, I think, because there is only the mailing list that is great for discussions, but maybe not as convenient, and it's not easy to navigate. Some people are reluctant to actually join Erlang mailing lists and discuss anything on there. So this opened the kind of this has like immediate effect on community. The people started joining there, starting to communicate, started to figure out new things, started to share expertise and build that expertise. And with that, it's not just forums, all the tools that are there. For example, we know that Erlang was open sourced in 1998, I think, but it wasn't as easy to actually hack on it until it was finally moved to a more accessible storage, which is GitHub. So as soon as it happened, that helped people to understand, okay, this is how it works. This is how I can collaborate, how I can kind of navigate all of that. And it now happens even better. So for example, like previously, if we find an issue with Erlang, we had to use quite a cryptic Jura system that Ericsson was supporting. It was possible. I managed to file a few bugs and watch that progress, but it wasn't as convenient, and it was disconnected from the rest of the world. So relatively new things like moving that development to GitHub definitely opened up a lot more possibilities to community. So I found so many people actually contributing and filing those bugs. And this is another good way to grow the community, to connect it. That's at least something that I can think of.
Right. Yeah, and I think in particular the progress has been made by the OTP team, like you said, moving to GitHub, but also I feel like they're much more approachable now. They were always on the mailing list, but they're also in other forums now, and that's really great. And I think another like important, I don't know, development is the introduction of Hex. Like before Hex came along, basically the best practice or the common way of pulling in dependencies was simply directly from GitHub. And then I'm sure you know the many projects that were forked on GitHub, so you never quite knew which was like the canonical version, and you know, it was very difficult to keep track of what you're actually using. And I think that's like supply chain security is becoming much more important these days. It's very important that you know which third-party code you're using, which version you are using, and if a vulnerability is found, that you can quickly tell if you are vulnerable. And I think just having Hex as a centralized place, and the work Eric is doing and the rest of the team to also address potential security issues around supply chain security. For example, Hex diff, which lets you see the actual changes that were introduced from one version to another of a package, without not just pulling in a new version without seeing a line of code. You can actually quickly see what has changed, and yes, this is safe for me to merge into the next version of my own project. So I think there are definitely changes, improvements being made. Yeah, we should probably point out the secure coding and deployment hardening guidelines that we published as part of the EEF security working group. So hopefully that can help some people. So now, if people want to, I don't know, share their experiences, as you said, it's important for the community to share and to help one another. So how can people get involved? How can they help others so that, you know, others might help them?
So there are different ways to define what is help. Some help just is like a very simple kind of question and answer thing. For example, like I want to know how to configure this thing. I Googled twice, I Googled 3 times, and I still didn't find how to use it because like either there is no information or I'm not yet ready to read the complicated code that is somewhere here or somewhere there. So how do I start with? For these kinds of communications, it is kind of, there are different mediums that we could use. Like for example, there is very active Slack channel, and you can actually get an invite for that Slack channel by joining Erlang Ecosystem Foundation. So when you join, it doesn't really matter whether you're a paid member or not. When you join, you can ask to, hey, can I join the Slack channel that is specifically about security on Erlang. It's even called Security Working Group because it's managed by Security Working Group for Erlang Ecosystem Foundation. If you have a more generic question that touches more than just security, you can use other channels that are there on Slack. That is to get some kind of immediate answer if you just have a very simple question to ask. But if it is something more more difficult, or for example, you want to understand what are the best practices to do secure way of this or kind of hardened deployment of that. So how do I do that specifically? Or maybe if you actually already know how to do that and you actually want to share, you want to actually leave your trace in the history there, in the Erlang and Elixir development history, what you can do is just the best. You can just, you don't even have to join the Erlang Ecosystem Foundation. You can just make a pull request, because these guidelines, they are actually published. They are on GitHub. You can make your contribution there, and if it's a great contribution, apparently it will be included in the next edition, and the people will definitely thank you for contributing there. These are all kind of ways that you can share your expertise. You can pick some other person brain, or what you can do is just you can join either unfortunately not very regular but still happening meetings within the community. Bram, you can probably talk about it because you organize that.
Well, yeah. So I mean, you mentioned the EEF Security Working Group, and I don't want this to turn into some sort of advert, but I mean, we're both active in the working group, and we kind of want to push things to the next level, because not enough has happened, right? As you can see in the poll results, so the biggest concern most people have is the skill set of people, which and the lack of documentation, which of course relates to each other, right? If there's information available, then people can build their own skills, and that might address the skill shortage. So I think the EEF Security Working Group can definitely help there, not more than just the secure coding guidelines. Secure coding is like a specific part of the secure software development lifecycle. It's like when you're actually sitting at your editor and typing, and you want to catch things early. You don't want to code something that introduces a vulnerability, and then 3 months later, when this code goes through some sort of penetration testing, find out that actually you did something that was considered a bad idea. Secure coding is like a set of guidelines, best practices for that a developer can use as they are coding to prevent certain vulnerabilities or weaknesses from being introduced. So that's one part of a secure development lifecycle, but I think there's much more to it, in particular like testing, for example. Maybe we need documentation on testing. Another thing is the secure coding guidelines currently only cover Erlang and Elixir standard library, but maybe we need to cover third-party libraries as well, maybe Phoenix, Cowboy. There's definitely things to be done, and we would very much like to get some fresh blood into the working group. We're currently planning a call on the 17th of November. So if someone wants to join, we're welcome to join. And like you said, it's important not to just to join because you think you have something to contribute. You can also join in order to just help ask questions and share experiences, and help identify like where is the work needed, what work is needed, where is it needed, and then we can all gather some people together who can maybe help make this happen. So yeah, if there's one takeaway from this conversation, is that as a community we can move this forward, and I think the EEF Security Working Group can play a role in that, but it can also be in other forums. I think we need to wrap things up soon. So is there anything you might want to add?
I was just going to add that even if you don't plan to contribute right now to securing the Beam or securing the community or securing the ecosystem, but you either participated in some vulnerability disclosure that has been now buried under corporate documentation and so on, so maybe no one really remembers about those things. You can still contribute just by surfacing, oh, we had that security problem. And maybe in a week or so, there will be an additional clause in either secure coding guidelines or in some best practices saying that there has been a case of this, or maybe it's just a CVE, but just you don't know how to report it. Because to be honest, I have not reported CVE for that, just the process is cumbersome. It's not super user-friendly, and like there are many things associated with it. So even if you just know, okay, this is insecure, I don't know how to make it secure, surfacing it already helps. This is also a contribution.
Or if you're not really sure, if you think maybe there is something there that needs to be looked at by someone who maybe with more experience, or you just want to bounce some ideas off of someone, that I think, you know, there are forums for that, and we would love to hear, definitely. Anyone in the audience wants to you know, raise any topic, ask a question or anything, because again, this is intended to be interactive. Feel free to unmute or raise your hand or whatever.
Yeah. So the way it works, you just unmute yourself and just ask a question. Oh, we have actually a question from the auditorium.
Earlier, you talked about how Erlang distribution is not well. Have you looked into your question from the audience?
Yeah, so the question was, earlier I mentioned that it may not be exactly safe to enable communications through Erlang distributions between all the nodes in the world. And the question was whether there were any considerations of actually how to make it secure. So yes, there was actually a lot of work done even before. Even before 2000 came, there were plenty of, I think, PhDs or similar papers made by people that work at Ericsson now. They are all called, if I'm not mistaken, Secure Erlang. They are probably slightly outdated right now. They include more than just distribution security. So they were mostly scientific papers. I am not aware of any existing implementation of that, however, so maybe there were some implementations, maybe there weren't, I haven't seen them. That was one thing. Another thing was a SecCom proposal last year in the security working group that we also kind of discussed, which was less about sending, like security of sending messages between different processes in the world, but more about calling functions by some processes. So literally not a firewall for messages, but firewall for functions. Since sending a message is also a function, then probably there is some way to tie it up somehow. So there was such a project, but I think the implementation also did not proceed, for there was not enough understanding of how to model this within Erlang, because it's actually an interesting problem with Erlang. It is so simple that it sometimes gets very difficult to actually carefully weave the new thing in it, like, because it's so beautifully simple that as soon as you start adding like security things, it just looks awkward and ugly and doesn't really work in many cases. And of course, there are other ideas that we entertain, not necessarily within security working group, of how to make, in this case, Erlang distribution more secure. Right now, Erlang distribution follows a perimeter security model. So literally, if you have a cluster of nodes and the attacker compromised one node, the attacker can do anything with all the nodes in the cluster. So as soon as you're inside the security perimeter, you can do anything with it. Modern software security tendencies tend to kind of get to node-based perimeter, where if you compromised one node, you have just one node, but you don't have anything else from other nodes. We are trying to look into what we can do about that, but it's not an easy job, because on one side we want to have transparent distribution, on the other side we want to make that transparency not exactly transparent.
Right. So in the deployment hardening, we actually talk about the like if you're talking about like a multi-tier architecture, so it's okay to use distribution across a layer of in the architecture, because probably lateral movement is any case it's probably possible anyway. Like if an attacker can compromise one node, they could probably also compromise another node directly. So the fact that they can hop horizontally doesn't really change your, the way your system has been compromised. But don't use Erlang distribution, for example, to connect a front-end layer to a back-end layer, because then if your front-end is compromised, immediately your back-end is also compromised. So between your front-end and your back-end, use HTTP or a database interface or something like that. That would be my my primary recommendation. And of course, there's much more to be researched and maybe documented. I think we need to wrap things up, right? Maybe if someone has something really quick, we can.
Yeah, we have time for one more question.
If there is one. I thought Frank was going to say something, but I think Frank left. Where is he? No, Frank left. Okay.
All right, thank you, Bram. Maybe you want to now display poll results, or maybe say what the people are considering to be like the real challenges.
Yeah, I touched a bit upon the poll results. So basically, the 44% of people said that their main concern is the difficulty finding people with the right skill set. Second, at 15%, was the availability or the quality of libraries for standards around authentication and crypto. And then a few people here or there had some other answers. Nobody said none of the above. Two people said nothing. I feel I made the right choice with Beam, which is good. Okay, good, happy for you. Okay, anyway. Thank you, Maxim, and thanks everyone for your attention.